Activity. Take a small colored paper pellet and put it in a beaker half filled with water. Place the beaker on a tripod stand and heat it. As the water warms up, you will observe that the paper pellet is moving upward along with the warm layers of water and then sinks back along with the cooler layers of water. The molten magma inside the earth moves in a similar manner. The lithosphere is broken into a number of plates known as the lithospheric plates. You will be surprised to know that these plates move around very slowly, just a few millimeters each year. This is because of the movement of the molten magma inside the earth. The molten magma inside the earth moves in a circular manner as shown in the activity. The movement of these plates causes changes on the surface of the earth. The earth movements are divided on the basis of the forces which cause them. The forces which act in the interior of the earth are called as endogenic forces and the forces that work on the surface of the earth are called as exogenic forces. Fig. 3.1. Earth movements. Endogenic forces. Exogenic forces. Sudden forces. Diastrophic forces. Erosional and depositional. Earthquake. Building mountains. River. Glossary. Lithospheric plates. The Earth's crust consists of several large and some small, rigid, irregularly shaped plates, slabs, which carry continents and the ocean floor. Volcano. Landslides. Wind. Sea waves. Glaciers. Fig. 3.1. Evolution of landforms. Endogenic forces sometimes produce sudden movements and at the other times produce slow movements. Sudden movements like earthquakes and volcanoes cause mass destruction over the surface of the earth. A volcano is a vent, opening in the earth's crust through which molten material erupts suddenly. Fig. 3.2. Word origin. Endo. Inside, exo, outside. Endogenic. Gases and ash. Crater. Wind. Plus genic. Origin. Exogenic. Lava. Activity. Crust. Mantle. Fig. 3.2. A volcano. Similarly, when the lithospheric plates move, the surface of the earth vibrates. The vibrations can travel all round the earth. These vibrations are called earthquakes. Fig. 3.3. The place in the crust where the movement starts is called the focus. The place on the surface above the focus is called the epicenter. Vibrations travel outwards from the epicenter as waves. Greatest damage is usually closest to the epicenter and the strength of the earthquake decreases away from the center. Magma chamber. Take a container, fill it with water and close it with a lid. Put the water to boil. Now put some peas, spoon and beads on top on the lid. What do you notice? As the water boils, the lid begins to shake. The things which you have put on the lid also vibrate. The beads roll down and the spoon vibrates to make a sound. In the same manner, the earth vibrates when an earthquake occurs. Plate boundary. Epicenter. Seismic waves radiate out in all directions. Do you know? There are three types of earthquake waves. 1. P waves or longitudinal waves. 2. S waves or transverse waves. 3. L waves or surface waves. Try to find out the properties of these waves from an encyclopedia. Focus. This is where the earthquake occurs. It is the origin of the seismic energy. No. Fig. 3.3. Origin of an earthquake. Although earthquakes cannot be predicted, the impact can certainly be minimized if we are prepared beforehand. Some common earthquake prediction methods adopted locally by people include studying animal behavior. Fish in the ponds get agitated, snakes come to the surface. Earthquake, a case study. Fig. 3.3a. Destruction caused by an earthquake in Gujarat. Do you know? An earthquake is measured with a machine called a measured on the earthquake of 2.0 or little. An earthquake damage from things higher magnitude is considered very strong and 7.0 is classified as a major earthquake. Seismograph. The magnitude of the earthquake is Richter scale. In the less can be felt only a over 5.0 can cause falling. A 6.0 or earthquake preparedness. Where to take shelter during an earthquake. Safe spot under a kitchen counter, table or desk. A seismograph. Earthquake hits Bhuj. A massive earthquake measuring 6.9 on Richter scale hit Bhuj down on the 26th of January 2001. 2 schools worst affected. At least 971 students and 31 teachers are feared to have lost their lives following the collapse of school buildings. 3 Bhuj relief effort blighted. 3 days after the quake, concern rose about food, blankets, and medical supplies not reaching everyone. 4 Destruction of Bhuj. Phone lines, water, pipelines and power stations transmission lines were knocked out. 15 Fire in the city. Hundreds of fires started as charcoal, cookers overturned. 6 Emergency declared in quake zone. The president declares a state of emergency. CM's appeal to Gujarat appeals for financial help. The Chief Minister of Gujarat has launched the center an appeal for the center to deal with the disaster. Activity 1. Read the earthquake, a case study given in the form of headlines that appeared in the newspapers after the quake. Arrange the events in the right sequence of their happening. 2. Imagine if a quake suddenly shook in the middle of the school day. Where would you go for safety? Against an inside corner or wall. Stay away from fireplaces, areas around chimneys, windows that shatter including mirrors and picture frames. Be prepared, spread awareness amongst your friends and family members and face any disaster confidently. Major landforms. Do you know? The landscape is being continuously worn away by 2 processes: weathering and erosion. Weathering is the breaking up of the rocks on the Earth's surface. Erosion is the wearing away of the landscape by different agents like water, wind and ice. The eroded material is carried away or transported by water, wind, etc. and eventually deposited. This process of erosion and deposition create different landforms on the surface of the earth. Work of a river. The running water in the river erodes the landscape. When the river tumbles at steep angle over very hard rocks or down a steep valley side, it forms a waterfall. Fig. 3.4. Hard rock. Softer rock undercut by the power of the water. Fig. 3.4. Waterfall. As the river enters the plain, it twists and turns, forming large bends known as meanders. Due to continuous erosion and deposition along the sides of the meander, the ends of the meander loop come closer and closer. In due course of time, the meander loop cuts off from the river and forms a cut-off lake, also called an oxbow lake. At times the river overflows its banks. This leads to the flooding of the deposits, layers of fine soil and other material called sediments along its banks. This leads to the formation of a flat, fertile floodplain. The raised banks are called levees. As the river approaches the sea, the speed of the flowing water decreases in the neighboring areas. As it floods, it oxbow lake. There are thousands of small waterfalls in the world. The highest waterfall is Angel Falls of Venezuela in South America. The other waterfalls are Niagara Falls, located on the border between Canada and USA in North America, and Victoria Falls on the borders of Zambia and Zimbabwe in Africa. The Niagara Falls. Floodplains. Silica. Greater than levees. Mean. Fig. 3.5. Features made by a river in a floodplain. Let's do. Find out the names of a few rivers of the world that form a delta. Main river. Distributary. River begins to break up into a number of streams called distributaries. The river becomes so slow that it begins to deposit its load. Each distributary forms its own mouth. The collection of sediments from all the mouths forms a delta. Fig. 3.6, a delta. Work of sea waves. Stack. Sea arch. Fig. 3.7, features made by sea waves. Sea cave. The erosion and deposition of the sea waves gives rise to coastal landforms. Sea waves continuously strike at the rocks. Cracks develop. Over time they become larger and wider. Thus, hollow-like caves are formed on the rocks. They are called sea caves. As these cavities become bigger and bigger, only the roof of the caves remain, thus forming sea arches. Further, erosion breaks the roof and only walls are left. These wall-like features are called stacks. The steep rocky coast rising almost vertically above sea water is called sea cliff. The sea waves deposit sediments along the shores forming beaches. Work of ice. Glaciers are rivers of ice which too erode the landscape by bulldozing soil and stones to expose the solid rock below. Glaciers carve out deep hollows there. As the ice melts, they get filled up with water and become beautiful lakes in the mountains. The material carried by the glaciers, such as rocks big and small, sand and silt, gets deposited. These deposits form glacial moraines. Fig. 3.8, a galactor. Work of wind. Have you ever visited a desert? Try to collect some pictures of sand dunes. An active agent of erosion and deposition in the deserts is wind. In deserts you can see rocks in the shape of a mushroom, commonly called mushroom rocks. Winds erode the lower section of the rock more than the upper part. Therefore, such rocks have narrower base and wider top. When the wind blows, it lifts and transports sand from one place to another. When it stops blowing, the sand falls and gets deposited in low hill-like structures. These are called sand dunes. Fig. 3.9. When the grains of sand are very fine and light, the wind can carry it over very long distances. When such sand is deposited in large areas, it is called loess. Large deposits of loess is found in China. Fig. 3.9, sand dunes.